Hello, Marcellus. Algebra 2, let's go. This is part 2 of this week. Multiplying radicals. We did adding and subtracting, and we had some rules and how we add and subtract them. They're very basic, but when you multiply them, you need a totally different strategy. All right, and so we want to make sure that we kind of put this on its own shelf, okay, and understand that adding, subtracting, multiplying, three totally different operations. Adding and subtracting are basically kind of the same thing. But multiplying and dividing are totally different animals. And so what we got to do is we have to make sure how do we handle that. All right. And so if you remember that if I had, say, the square root of 2, let me autofocus here. Not good. Okay, radical 2, now this means that I have an index of 2 here and a radicand of 2. Now the index of 2 is always invisible. We never write it, just like we never write x to the first power. All right, we just always assume that because it's there, it's to the first power. So radical 2, let's just actually go ahead and multiply it. Like your homework's going to look something like this. Okay, there. Okay. Where we have a monomial here being distributed to a binomial expression. Now 3 plus radical 3 is some decimal, all right? A very, very long decimal, goes on to infinity. This is also an infinitely large non-repeating decimal, so if I were to multiply two of them together, I'm going to get another large non-repeating decimal value. So this is a lot easier actually to do instead of a calculator because this carries with it all of those decimals, all right, as a symbol. And so it's very good and very important to become acquainted with these. All right, so let's go ahead and, if this was just a regular 2, we would distribute, right? Okay, and that's what we're going to do here. But our new rule actually is going to look like this. Whenever you're multiplying two radicals, your book does this very quickly because it actually assumes that you already knew this from geometry, and everyone either always forgets this or it was not covered just due to time constraints. And so let's say that I have radical x and I want to multiply to radical y. Okay, now you can see here that they actually do have the same index here. It is an index of 2, and if that is the case, then it will remain, your product will actually have a index of 2. It will retain it. But the product is actually the two radicands put together is now a new radicand. All right? So it's pretty simple. If it's underneath the radical symbol, it stays in the radical symbol. And then you just look for pairs and you take those pairs out. All right? Now, if this was actually a 3 here and I left that a 2, can't do it. All right. Not only, they have different indices, so you can't multiply them straightforward like this. But if I did do this and multiplied those two cube roots of x and y, all right, then this is correct as long as I keep and retain that cube root, all right, that index of 3. So the radical just kind of stays the same as we march across, all right, making sure that the coefficients stay with the coefficients and the radicands stay with the radicands. All right, so let's just go ahead and distribute this one here. And if I multiply it to here, notice that 3 is not a radicand, all right, but he is a coefficient, right? He doesn't have a radical, so he is just going to attach to that radical 2, but he's just going to come out in front, okay? Just like if this was x squared times 3, it would just be 3x squared, okay? It's the same principle. Now here, when I distribute the radical 2 to the radical 3, two positives when I multiply create a positive, and this is actually going to give me radical, not 5, but 6. All right, and if you remember that you're always supposed to look for identical factors, all right, or roots within inside the 6, and our factors here, a lot of people think that the square root of 6 is just 3 radical 3. Because they want to take a pair of 3's out, and then they have 3 left over, I don't know, something. Or they just say that the square root of 6 is 3. All right, and that's no. Okay, we want to look at it like this. We have two prime numbers. One is a 3, one is a 2. There are no pairs. So radical 6 just stays radical 6. In fact, that is the answer. All right, 3 radical 2 plus radical 6. That's it. That's all you got. So this is your final answer, and you would circle it. Okay, so no big deal. All right, so let's put that example 1. Example 2, I wrote it down here somewhere. All right, what if this is just going to increase in complexity? Let's say we got 2 radical 5 being multiplied to 9 minus radical 3. Okay, so pretty straightforward. The 2 radical 5 times 9. Now the 9 does not have a radical, so he is not a radicand. He will not combine with the 5, but he will multiply to the 2 here. So we have 18 radical 5. Okay, radical 5 is just that attachment. It's going to stay almost like a variable. All right. All right, and then we proceed forward. We're going to multiply this. Okay, we multiplied here. Now we're going to multiply this guy. Now 2 times an invisible negative 1 here. He'll stay negative. But then now I do have 2 radicands with the same index, and so I can actually do radical 15. All right, and then before you move forward, just think, well, is there anything inside 15 that is a pair? Nope. Okay, just 5 times 3. These are both prime factors. So that is my final answer. All right. Example 3. All right, so we got radical 2 plus radical 5. And then this is 1 minus radical 5. Now, in these 4 examples that we're going to do, it's pretty much going to cover all of the basics that you're going to not only see on your homework, but it's just such a fundamental skill for moving into pre-calc and calculus and moving forward. Okay, so radical 2 times 1. Now this is just kind of FOIL, right? So we just have to make sure that we multiply 4 things total, right? Because we have a 2 by 2 here. And radical 2 times 1 is just radical 2. Radical 2 times negative radical 5 is actually a negative radical 10. I'll worry about simplifying him later. This is radical 5 times 1, which is just plus radical 5, okay, with an invisible 1 out in front. And then we get radical 5 times a negative radical 5, which is minus, or negative, 5 times 5 is 25. Okay, so I make sure that these are all simplified. Radical 2 is good. Inside 10 is just 5 and 2, so that's going to stay radical 10. Radical 5 is just radical 5. And then this guy right here, the square root of 25 is actually 5, and so that's minus 5. Now, believe it or not, we're done because these guys cannot combine. If you remember from the last video for adding and subtracting radicals, these guys have to have the same index and radicand in order to add and subtract. Okay. Same index, same radicand. When you multiply, you just need the same index. You do not need identical radicands. Okay, so this is cooked, this is done. Okay. All right, and then finally our last example, and this would be kind of the, what are we pushing at? Okay, about 10 minutes here. What if you have like, I noticed this kind of ended up on your homework. What if you got a variable in there? And the answer is, so what? No big deal. He's just there. If you don't have a pair of them, he stays. All right, if you cannot take anything out of the radicand, or you cannot take anything out of the radical unless there's pairs of them, or in this case, triples, or if it's a 5th power, quintuplets of them. All right. Okay, so we got 4 and then radical 2. Okay, so this is the extent. This is as hard as it gets for today's homework, and again, it's just 18 problems. Try to get that in, try to do it before the weekend. I want to do division. I don't want this stuff to pile up on you. Just try to stay in pace with it. I mean, it's pretty much I won't say no rush, but it's like, be cool about it. Try to use that free time wisely, and, you don't want to get it all overwhelmed, and then next year, you're going to have about, you're going to have half the Algebra 2 students remembering this stuff, and like, you're going to struggle, okay? So make sure that, you do stay with us, okay? Because it's going to be really challenging next year if half of you are engaged and the other half falls. Or I won't say falls, but falls, fall apart if it's overwhelming. All right, so there's my lecture of the day. Okay, so that's it. 2x times 7 is just 14x. It stays in the radical. They both have the same index. I'm good to go. That's my first term. My second term is now going to go here. All right, and let's see. I have a 4 out in front. I have a positive 1 here, so we'll stay positive. Radical 2x times radical 2 is radical 4x. Okay, now I know the square root of 4 is 2. I'll take care of that in just a second. Let me get the other guys. All right, and then this is going to be negative. That's a positive, so it'll be a negative. This will be radical 70. I'll worry about simplifying him in a second. And then finally, he has two components here still. Well, negative 1 and a 4 and a 2. So this negative 1 times 4 is negative 4. And then 10 times 2 is 20. So let's put radical 20. Okay, so I've pretty much done the hard part. Everything else now is just looking for identical pairs because the index is 2. And I believe your homework, all of the indices are 2. I believe. All right, they're all the same anyways. Okay, inside 14 is just 2 times 7, not a pair of 7s. That's addition. That's 7 plus 7, not 7 times 7. All right, so he's going to stay radical 14x. This guy, we can take the square root of 2, so he's going to come out as 2. And so since a 4 is already there, he will get multiplied to him. All right, so now the square root of 4 is 2, so 2 times 4 is 8, and that x is going to remain, so we got the square root of x. All right, now inside 70, let's see, we got 25 times, no we don't, we've got 7 times 10, and 7 is prime, 2 and 5 is prime. Nope, he's good. Okay. All right, so oddly enough, radical 70 is, can't simplify it. Now inside 20 is 4 and 5, so we're going to take the square root of 4, that's 2, so we get a negative 8, and then we have a 5 still remaining on the inside. And I just want to check and make sure that these are all different, and they are, so therefore I'm finished. There's nowhere else for me to go. Okay, so that is our actual answer. All right, so 1 through 18, enjoy, and again, try to stay ahead of the game. It looks like I'm only got about, out of 48 people, there's only about little less than half of you like kind of following along and turning stuff in. So again, there's no due dates to this stuff, but I really do want to encourage you to kind of just stay in the mix here. I'm going to do my best to not like make long like 30-minute videos, but kind of keep them like every other day, like a quick 10, quick 15. I'm going to try to kind of pace it out like that, but it all depends on how terrible my kids are being. So everybody be safe, and I will put out another one tomorrow. All right? Have a great evening.